Welcome to Understand the Math. In this video, I'm going to go over 7 examples and show you how to simplify different types of trigonometric expressions. Before you begin, be sure to check out the video description below for a link to free guided notes that you can download and fill in as you watch this video. Before we dive into the examples, let's quickly go over the techniques we can use to simplify a trigonometric expression. Simplifying a trigonometric expression involves rewriting a more complicated expression as a more simple expression that's easier to work with. I've listed 6 common algebra techniques that we can use. The first technique is when we can factor out an expression. We can write AB plus AC as A times B plus C and factor out the A. A squared plus 2AB plus B squared can be written as the quantity A plus B squared, or A squared minus 2AB plus B squared can be written as A minus B quantity squared. Lastly, A squared minus B squared can be written as A plus B times A minus B. The next technique we can use is to multiply out an expression. A times the quantity B plus C can be written as AB plus AC. The next technique is when we can add fractions by getting a common denominator. A divided by B plus C divided by D has a common denominator of B times D. So our numerator looks like AD plus BC. The next technique is one that you don't often think to use, and it is when you multiply by a conjugate. We can write 1 over A minus B as 1 divided by A minus B times A plus B in the numerator and A plus B in the denominator. Likewise, we can write 1 over A plus B as 1 over A plus B times A minus B divided by A minus B. The fifth technique is one where we can split a fraction into 2 fractions, and we can do this if there's a single term in the denominator. We can write A plus B divided by C as A divided by C plus B divided by C. The last technique we can use is to multiply by 1. For example, we could let 1 be equal to cosine x divided by cosine x. And that's also a difficult one and a little bit hard to think of. For our first example, let's write secant x as 1 divided by cosine x, since we know that sine x divided by cosine x is tangent x. We have sine x times 1 divided by cosine x, all divided by tangent x. Tangent x is sine x divided by cosine x. So this becomes tangent x on the top, and we have a tangent x on the bottom. This simplifies to a value of 1. In our second example, we can see that we have a tangent squared and a secant squared. So we need to remember our Pythagorean identity, which says that tangent squared x plus 1 is secant squared x. Let's solve for tangent squared. So we can write tangent squared x as secant squared x minus 1 and plug this into our numerator. This gives us 2 plus secant squared x minus 1 all divided by secant squared x minus 1. This gives us 1 plus secant squared x on the top, secant squared x in the denominator, and then we're still subtracting 1. We have two terms, and we can get a common denominator. Our common denominator is going to be secant squared x. So our numerator looks like 1 plus secant squared x over secant squared x, and then our 1 will change to be secant squared x divided by secant squared x. This gives us 1 plus secant squared x minus secant squared x, all divided by secant squared x, which is 1 divided by secant squared x. And we know that 1 divided by secant x is cosine x. So our answer can be written as cosine squared x. In example 3, we can see that we have a cosine x common to both terms, so we can pull that out. We'll factor out a cosine x from each term, and we're left with a cosine squared x plus sine squared x. We know that sine squared x plus cosine squared x is equal to 1, so this simplifies to just cosine x. In example 4, we're going to need to use factoring. This one is a pretty difficult example. We'll start by noticing that it's a difference of squares. Let's write down what a squared minus b squared equals. We have a squared minus b squared, and that's equal to a plus b times a minus b. Now we don't have a squared minus b squared on the left. We have something like a to the fourth minus b to the fourth. So let's write that down. So we can say that a to the fourth minus b to the fourth is going to be a squared plus b squared, using this as our guide, times a squared minus b squared. So we're just plugging in wherever we have a, we're going to plug in a squared. Let's now notice that our a is sine x and our b is cosine x. So we can write this as a squared, which is sine squared x, plus b squared, which is cosine squared x, times sine squared x minus cosine squared x. We can then recognize this is equal to 1 from our Pythagorean identity. So this just gives us sine squared x minus cosine squared x. And that's as simple as we can make that expression. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. In example number 5, we can start by multiplying out tangent x. This gives us tangent x times cosine x minus tangent x times cosecant x. Let's use the fact that tangent x is equal to sine x over cosine x to see if we can simplify this further. We'll plug that in. So tangent x is sine x divided by cosine x times cosine x. That's great. We see that the cosines are going to cancel. Minus, plugging that in again, tangent x is sine x divided by cosine x times cosecant x. Our cosines cancel on our left term, so we have just a sine x. And then let's notice that cosecant x is 1 divided by sine x, so we can plug that in. So this becomes minus sine x divided by cosine x times 1 divided by sine x. And we can see that our sine x cancels. This gives us sine x minus 1 over cosine x. And then we know that 1 divided by cosine x is secant x. This gives us sine x minus secant x. In example 6, we have two fractions, so we'll begin by getting a common denominator. Our common denominator is cosine x times 1 plus sine x. Our top term, 1 plus sine x, now gets multiplied by a 1 plus sine x. Let's extend this line out. And then our cosine x gets multiplied by a cosine x. Let's then multiply these terms out. We have a 1 plus 2 sine x plus sine squared x plus cosine squared x. Already we can see something good there with the sine squared plus the cosine squared. And on the bottom, we just recopy what we have. Cosine x times 1 plus sine x. We see that this expression is our Pythagorean expression, and it's going to equal 1. So let's plug that in. So this becomes 1 plus 2 sine x plus 1, all divided by cosine x times 1 plus sine x. I always tell students when they're working through these problems that it's really good practice for when you take calculus, because when you do calculus problems, you have to do a lot of simplification like this. Let's now combine the ones. So this is 2 plus 2 sine x, all divided by cosine x times 1 plus sine x. We can see that we can take a 2 out of each term in our numerator. So let's pull that out. So this is 2 times 1 plus sine x. And then you can see something good. We're also, in our denominator, we have a 1 plus sine x. So that's great. That cancels out. And we're left with a 2 divided by cosine x, which is just 2 times secant x. Example 7 is a pretty common example, but it's a really difficult one because you have to recognize right at the beginning that you need to multiply by a conjugate. We can write 1 divided by a minus b as 1 divided by a minus b times a plus b divided by a plus b. A plus b is the conjugate of a minus b. This gives us sine x divided by 1 minus cosine x. Now we're going to multiply by the conjugate. So our conjugate is going to be 1 plus cosine x divided by 1 plus cosine x. So we're just multiplying by 1, and it's not going to change the problem. Let's multiply out the bottom term, but let's not multiply out the top term yet because we just don't know if we need to. So our bottom term looks like 1. We have a minus cosine x and a positive cosine x. They cancel. So we just have 1 minus cosine squared x. Our Pythagorean identity is sine squared x plus cosine squared x is equal to 1. So we can see that sine squared x is 1 minus cosine squared x, and we can plug that in. Our top stays the same, sine x times 1 plus cosine x. And then our denominator becomes sine squared x. And we can see that we can divide out one of the sine squares. So we're left with 1 plus cosine x divided by sine x. Since we have one term in the denominator, we can split this into two fractions. So this is 1 divided by sine x plus cosine x divided by sine x. And this is equal to cosecant x plus cotangent x. That was a lot of work, but we did it. Since these problems are so difficult, I would suggest that you go back through these problems and work on them until you can do them completely on your own, and then also do other example problems. It just takes doing a lot of problems to be good at learning how to simplify these types of trigonometric expressions.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.